Hi everyone. Today we are going to discuss our next concept in utilization of electrical energy subject. This one is nothing but tariff. And this particular thing, let it be. Let's start our session with let it be. I'd like to have some power plant here, and this power plant I would like to expect some sort of electrical energy as output. In order to expect output as electrical energy, we are having some generation plant there. In this one, I would like to invest some cost there for each and every part of generating electrical energy. I invest some cost. And while I build this particular electrical energy, I would like to give it to some other thing with the help of some transmission section and distribution section for the customers there. I expect something here. I that it is nothing but I can expect some profit with the help of this particular investment there. How I can have this one is only one thing. Just observe the rate. It's in terms of rupees. The rate at which electrical energy is supplied to the consumers may be called it as tariff. That's the simple definition. The rate at which electrical energy is supplied to the consumers may be called it as tariff. And we are having some definition like this. This one is the definition. And coming to the part of objectives, I just want to invest something here that it is producing some electrical energy. That it is, I just want to recover that particular investment. Recovery of cost of producing electrical energy. One of the objectives. Recovery of cost of on the capital investment in terms of transmission and distribution systems also there, and recovery of cost of while having this particular transmission and distribution, we have some operation and maintenance also there. Have to keep into mind, in order to recover all these things what I have invested there, then we expect some sort of suitable profit. This one is the main objectives of which thing here, tariff. What are the desirable characteristics of a tariff here is, these are the desirable characteristics here. We can expect some sort of proper return. Yeah. What's that proper return in the sense? I have some cost of producing electrical energy plus some profit there. And in terms of proper return in the sense, with the help of that electrical power supply company, we'll have some continuous and reliable service. If there is any dropout in the supply, the customers will not expect some output from the particular company. Fairness in deal there. Yeah. Different types of consumers are satisfied with the rate of charge of electrical energy. That's a fairness there. Depends upon the customers that it is, whether it's in villages or in terms of industrial person. We have to maintain some specific rates in terms of fair deal. Next one, simplicity. Everyone can understand your particular bills. That's a simplicity there. Reasonable profit. Don't expect too much profit. Just we can expect up to the level of only 8% per the annum. That it is public utility company there. Attractive. Yeah, every customer will attract towards you only if you can have some reliable supply, and also we can expect some economical rates. Then only the customer will attract towards your company. These are the different desirable characteristics of tariff. Next one, what are the different types of tariff here is? We are having some different categories. The first and foremost thing here is simple tariff. What's that simple tariff is nothing but let it be we can have some for each and every unit. I just want to fix some 10 rupees per unit there. Irrespective of the customers, I just want to fix the 10 rupees. If you use some 100 units, you have to pay some 10 into 100. That's only simple deal. There is no variation in terms of ordinary people or to the part of industries. Every customer is same. That's the only thing of simple tariff. Yeah. There are so many disadvantages here. What are the disadvantages here is, there is no discrimination between different types of consumers. Why? It's a fixed charges. The cost per unit is also high there. That's a disadvantage. It does not encourage use of electricity here. Why? Means there is no categorization of this particular usage. That's the main drawback of simple tariff. What is meant by flat rate tariff here is, when different types of consumers are charged at different uniform rates. That it is, depends upon the situation. We can have some segregation there. Yeah, in this particular one, they can group some different classes. And what are the different classes here is, let it be you are having some lightning load. They can impose some rate here is 60 paise. Whereas for the another part power load, they can impose some sort of 55 paise there. there is some segregation. Depends upon that the previous simple tariff, we can have some flat rate tariff is some segregation. Then the customer will have some lighting load, some price, and whereas power load is some other different price. And coming to the part of disadvantage also for this particular one, separate meters are required for lightning and power load. Why means if you can't put this one, there is some other disadvantage there. This makes that something expensive, different meters now for lightning and power load. A particular class of consumers is charged at the same, irrespective of the part of energy consumed there. That's one more disadvantage there in terms of flat rate. Block rate in the sense we already know. Actually, let it we are having some different categories like this. We are having one block, two like this. Up to the part of 1 to 50, one block, 51 to 100 another block, 101 to 150 another block like this. If you can increase in the part of number of units consumed, there is some rate in the drop in the rate. This type of block rate tariff you can use it in the olden days, not now. Yeah, for example, the first 30 units may be charged at how much here? 60 paise. Next 25, 55 paise. Next 30 paise. There is some drop in the charges. And one more thing here is this tariff is used majorly for part of residential as well as commercial consumers there. Block rate tariff. Different blocks I can segregate. Another one is two-part tariff. Yeah, what is meant by two-part tariff here is the total charges they can segregate into two things there. This one is nothing but fixed charges B into kilowatt, whereas this one is running charges. How many units? What is kilowatt hour is nothing but how many units you can consume. That may indicates that kilowatt hour. Some constant B into kilowatt. It's a fixed charges. Whether you can use it or not, that's not an issue. You have to pay this particular bill. They can fix some 200 or something else. You have to pay it. And the second option here is these are the units consumed here. Those are nothing but running charges, and these are nothing but fixed charges. That's the only variation. Max and demand. Whether you can use it or not, that's not an issue. You have to pay it. Another one is charge per kilowatt hour of energy consumed. How many units you can consume, you have to pay it. This type of tariff is most applicable for industrial consumers. Yeah, there is a drawback. We have to pay this fixed charge now. That's why you have to go for the another one there. We can easily understand this one. We can easily recover the fixed charges. But the disadvantage here is every consumer has to pay that fixed charges. That's the main drawback. There is always an error in maximum demand. Yeah. In order to rectify this particular one, you have to go for the part of maximum demand tariff. The only variation in this maximum demand tariff here is you have to install one maximum demand meter. Yeah. The remaining one is same as two-part tariff, but you have to install one maximum demand meter on their premises. Then we can collect it only for the part of usage of maximum demand. That's the main thing of maximum demand tariff. Port factor tariff is also one more thing here. This type of tariff mainly depends upon the part of power factor that it is represented with the power factor in the sense cos phi. If there is any drop in the power factor, they can impose some extra charges on you. Yeah, that's the main thing. Another one, KVA maximum demand tariff is nothing but actually I know only one formula. Cos phi is equal to that P by S. S is nothing but KVA. If you are having some low power factor, obviously there is increase in the part of which thing KVA. Then they can impose some extra charges there. Sliding rate tariff is nothing but they can have some guidelines of power factor of 0.8. If there is any drop in the part of 0.8 power factor, they can impose some charges on you. If there is any increase in the power factor also, they can have some incentives for you there. That's the main difference here. Kilowatt and kVAR tariff is nothing but depends upon the kW is nothing but active power, kVAR is nothing but reactive power. Separately, they can segregate there. A consumer having low power factor will draw more reactive power. That's the main thing. Yeah, if you are having some cos phi is low means they can consume more reactive power, and obviously there is drop in the part of which thing active power P. These are one more classification of power factor tariff. Three-part tariff is nothing but it's similar to two-part that it is what's this B? It's an obviously fixed charges. This one is nothing but running charges, and this one is nothing but some constant here. That's nothing but fixed charge. What's that B is nothing but it's a maximum demand, whereas this one is nothing but how many units you can consume. That's the only thing. These are the total charges billing there. That may be nothing but fixed charges, semi-fixed charges, running charges. That's the only thing. The composition of these things may be called it as three-part tariff. Yeah, another one here is time of day tariff here. According to the part of electricity amendment rules in 2023, they can given some guidelines there. For commercial and industrial consumers, shall not have some 1.2 times the normal tariff there. Only thing of this time of tariff here is during the 24 hours duration of a particular day, we can have some peak hours. During that peak hours, if you can use some electricity, they can impose some extra charges on you. Yeah, that's 1.2 times. During normal hours, or that it is nothing but during solar hours, there is no charges will leverage on you. That's the only variation. During peak hours, they can impose some extra charges there. And in normal solar hours of the day, we cannot give anything there. They can also reduce some charges on you. That's the only variation, time of day. The name itself indicates time of day. These are the advantages here. Separate tariffs for peak hours, they can impose high rates. Whereas solar hours, normal hours, they can have some reduce in the tariff there. Depends upon our requirement, they can reduce. Yeah, that's the only thing. Coming to the part of numericals on this particular tariff, this one is one question. Yeah, just remember only one formula. Load factor is equal to average load by maximum demand. Can you change what's that average load is nothing but number of units consumed per year divided by hours in a year. Hours in a year is nothing but we can have some 8,760. Also, just substitute in this one. We can have some formula maybe like this. Load factor is equal to units consumed divided by maximum demand into the part of hours. From that, can evaluate what's the number of units formula here is. Number of units consumed is equal to maximum demand into load factor into hours in a year. That's the formula. Remember this formula. That may be helpful in order to solve this numerical. Yeah, they have given some numerical maybe like this. A consumer has a maximum demand of 200 kilowatts at 40% load factor. If the tariff is rupees 100 per kilowatt of maximum demand plus 10 paise per kilowatt hour. Find the overall cost per kilowatt hour. This one is a numerical. Just observe. I know the formula. Units consumed per year is equal to, from this formula, maximum demand into load factor into hours in a year. I know hours in a year here is 8,760. Load factor 40% now, 40 by 100, it's a 0.4. Maximum demand is 200. Then I can identify these are the number of units consumed per year. Annual charges is equal to annual maximum demand charges plus annual energy charges. This one is nothing but number of units consumed. That it is we know this one. Substitute here. The 10 paise per kilowatt hour they have indicated. 0.1 into these units. Annual maximum demand charges here is they impose rupees 100 per kilowatt now. Just 100 into 200. We get the annual charges there. These are the annual charges. Then the last question they can impose here is overall cost per kilowatt hour. That it is 90,000 divided by this number of units. We'll leverage some cost here. It's approximately 12 paise. This one is a simple numerical. Just only one formula. You have to remember load factor formula. That it is average load by maximum demand. That's the only thing. Next one. Yeah, this one is one more numerical. They have given some two tariffs like this. Offered 100 plus 15 paise per unit. Another tariff flat rate of 30 paise per unit. At what consumption is first tariff is economical? They can have some answer. First tariff is economical. Validate that question there. That it is plot some two graphs like this. One of the thing here is A graph is blue colored one. This B is red colored one. That it is second question is B. Flat rate is nothing but it starts from which thing here? 30 paise. Yeah. That's why I wrote some this one to up like this. This one starts from 100 rupees now. 100 rupees. They both join at some particular point. That maybe is the unknown quantity. What's the text stands for? Let this x be the number of units. You have to find out that one there. Both the tariffs become equal now. I join this point like this one x. Yeah, I just want to write this equation like this. What's the first equation? 100 plus pi sana 0.5x. X is unknown. Second one, I just want to know the number of units, 0.3x. Equate these two things like this and try to find out the x unknown. I just want to find out this one like this. It's approximately 666 units. This one is x value. Yeah. Yeah, let it be, it's approximately 700 like this. And substitute in this first equation and try to find out this value there. 100 plus 0.15, that is 75 like this. And we can get some value of 205 rupees. Whereas this one 0.3 into 700, it's approximately 210. Which one is the lower cost? Whether it's a 205 or 210? 205 is the economical one. Yeah, that's the validation. Yeah, after the point of this x, which one is dropping in rate here? This blue colored one is drop. This blue colored line is drop. That A is most economical compared to B after this point of x. That's only simple numerical there. That's the final one. Calculate the annual bill of a consumer whose maximum demand is 100 kilowatts, power factor of 0.8 lakh, and a load factor of 60%. The tariff used is 75 per kVA of maximum demand plus 15 paise per kilowatt hour. Just remember only one formula. What's the formula for cos phi? Kilowatt by kVA. From that, what's the value of kVA there? kW by cos phi. And I know one more formula, load factor is equal to average load by maximum demand. From that, can you substitute number of units consumed divided by hours in a year into maximum demand? This one is one more formula. From that, can you know the value of units, number of units consumed per year? Yes. Bring this one to this side, load factor into maximum demand into number of hours. Same thing for the similar to the first numerical. Yeah, we identified some value like this. Maximum demand is 100. Load factor is 60% of 0.6. Hours in a year here is 8,760. We get the value of units consumed right now. Maximum demand in kVA here is formula this one. I just want to use this formula. What's the value of kilowatt? 100. What's the value of power factor right now? 0.8. Substitute, we get the maximum demand value of 125. Try to go for annual bill. Maximum demand charges plus energy charges. Energy charges is nothing but how many units you can consume. These are the energy charges. I know 5.256 into 10 power of 5. And they can charges here is impose on how much paise here? 15 paise. 0.15 into this one. Maximum demand charges here is 75 into, I know the kVA value right now, 125. 75 into 125. We get some total charges of how much right now? It's approximately 88,250 rupees. That's the only thing. Yeah, remember load factor formula and this formula. That's enough in order to solve this numerical. That's it for today's session. Thank you for watching.